Friends, very good morning. Myself, Dr. M.H. Chennaya, and in today's video, we are going to work out a problem on the section of a square pyramid, which is resting on its base on HP, with two of the base edges equally inclined to VP. And here, this object is cut by a section plane normal to VP and parallel to one of the slant edges at a distance of so and so. Friends, when the pyramid is resting on its base on HP with two of the base edges equally inclined to VP, or all the four edges equally inclined to VP, let us obtain the top and front views of the square pyramid to the given dimension. So friends, I will just write down a square here. This is a square of the given size, that is 40 millimeter each side. I will just mark it as ABCD, and this ABCD represents the base of the solid, and the point where these two diagonals AC and BD intersect will give you O, the vertex. So this complete figure will give you top view of the square pyramid resting with two of the base edges, say AB and BC, equally inclined, means 45 degrees. And even AD and BC are also equally inclined to VP. So in this particular problem, all the four base edges of the solid are equally inclined to VP. Let's obtain the front view to the given size. So friends, from here, we'll write verticals through all these points, obtain the base of the solid ABCD. So I'll just mark it as A dash. This is B dash, D dash, the middle one, last is C dash. This is obtained on XY. This represents the base of this square pyramid. And from here, from the center of this, write the given height of the object, which is 65 millimeter. So I mark 65 millimeter height from X1, Y1, and we will obtain the front view. So join this O dash to A dash, O dash to C dash, etc., and obtain the front view of the solid. Here in this particular problem, even the axis or this line OB and OD is shown by dark line because the axis comes behind this OB. Friends, this is the front view of the solid and the corresponding top view of the solid we have drawn. Now let us move on to the section plane and see how the section plane is cutting the solid. Friends, in the front view, if you observe, the last two edges, namely O dash A dash and O dash C dash, represent the slant edges of the solid. So here he says there is a section plane which is normal to VP. So whenever the section plane is normal to VP, it is seen as a line in the front view. And that particular section plane is parallel to one of the slant edges. So it could be OA or it could be OC. So I mark a distance of 10 millimeter from here. So parallel to that O dash A dash, I am going to write a line. That is, I am going to write the line representing the section plane at a distance of 10 millimeter from the base. That is from the slant edge. So this vertical distance is 10 millimeter. And friends, this will give you the location of the section plane, which I mark it as S and S. So this will give you the section plane which is parallel to this at a distance of 10 mm. So we will see how we get cutting. So section plane I have got, and they are asking me to find out theta, the inclination of the section plane with HP. And friends, if you measure this angle using a protractor, this will give you theta. I will say measure it. That is the inclination of the section plane with the HP. Now I have the front view, I have the top view. The portion below the section plane SS is retained, whereas this portion is thrown out. So the retained part I am going to show by dark line. So this is the portion that is retained. This portion is retained. This is also retained. Friends, here the section plane SS, which is parallel to the slant edge O dash A dash, is cutting the solid here. This line represents the base of the solid, so it is cutting at this point. That is to know where exactly it is cutting. If you just write a vertical line from there, it is cutting base AD here, base AB at this point. So we can give some name to this later on. So there are 2 points where the section plane is cutting the base. Then comes this OC, O dash C dash, is cut here. And friends, from there, if you write a vertical line downwards, you will get a point here. So we have got 3 points. Again, this vertical line representing OB and OD are cut here. But OB and OD, they appear perpendicular here. So we do not know exactly where they cut. But you should remember that OC is inclined to HP, but the corresponding top view is parallel to VP, hence this is the true line. So to get the points where OB and OD are cut, I will just draw a line horizontal from this point till the last line. So from where it is cutting, I will just write a vertical from there. This is cutting the horizontal line. Taking O as center, the distance as radius, I am going to strike arcs on both the sides. So these are the 2 points where the section plane is cutting the slant edges OB and OD. So friends, here the section plane is cutting the base at 2 points, and 1, 2, 3 slant edges are also cut. That is OB, OD and OC. So basically there are 5 points where the section plane is cutting the solid. So friends, we will number those points one by one. If I start from here, so this I will call it as point 1, this is point 2, point 3, point 4 and point 5. So we'll join all those by straight lines. So we have got 1 to 2, 2 to 3, this is this point, then here we have got these points. So friends, in the top view you got 5 points. We are getting a distorted pentagon, and join this part. OC is still remaining, and the portion to the left of this point is removed, so we don't have this portion above this. So this is to be shown by thin line. This is existing, this edge is existing, this is existing, this is existing. So friends, here you can see here that this complete portion shown will represent the sectional top view STV of the object or the solid. This figure along with this will show you the front view of the solid, and we have got the sectional top view, we have got the front view, we have got theta already. Finally, we are left with finding out or drawing the true shape of the section. That means to obtain the true shape of the section, as usual, we are going to draw a line parallel to this SS. So this line is parallel to the section plane. And friends, before that, let me transfer these points here. 1 and 2 are here. So this is 1, 2. sorry, 1 comma 5 it is, 1 5, and this is 2 comma 4 is the point where these are cut, and this is point 3. So we got all the 5 points. Friends, from all these points, let us write down the lines perpendicular to this line, say x1, y1, some line which is drawn parallel to the section plane. And let's see how to obtain the true shape. So from every point here, I am going to draw the line perpendicular from that point. So 1 and 5 are here. So I write a line perpendicular to that, and on this line I mark 1 and 5. 5 is nearer, 1 is away. So the distance of 5 from xy is marked here. Suppose say I will call this as point 5. Then from xy to this is 1. So I will mark that as 1. So I got points 1 and 5. Likewise, from this is the other point, 2 and 4. So I will write down line perpendicular to this SS. So on this I am going to mark points 2 and 4. 4 is nearer and 2 is away. So this is 2 and this is 1, 2, 3. This is 4. Finally, friends, 3 is here. Measure the distance of 3 from xy. Transfer the distance onto the corresponding perpendicular line drawn. That will come exactly in between these two. So this is point 5. Friends, we have got all the 5 points which are used to draw the true shape. Join all these by straight line. So I join 1 to 2, 1 to 5, 5 to 4, sorry, 1, 2, this should be 3, sorry. 1, 2, 3, 4 and 5. All by straight lines. Join them by straight line. And friends, this figure 1, 2, 3, 4, 5 will represent the true shape of the section. I will call it as TS. It is a pentagon, a distorted pentagon. So we have obtained the complete projections of the solid when it is cut by a section plane which is normal to VP and parallel to this slanted O dash A dash, and this will give you the complete solution. Friends, if you are happy with the presentation you have seen, share this information with your friends without fail. Have a wonderful day. Thank you. Yeah, they were see.